All right. So first one looks like this. Write down yes or no. Do you think it's proportional? So this again is going to be your y-axis, and this will be your x. If this is the I don't want your verbal. I just want yes or no on your boards. See 3, 4, 5, 6. Yes, 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 yes. You're right. Good job. Good. 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 All right. Just about everybody here had no. I had a few people say yes. Why is it no? Somebody explain to the few that might not. Shawnee, what do you think?
For it to be graphically proportional, I think that's what you call it. The line has to start at 0.
Yes, and the line is not starting at 0. It's starting at a positive. Do we know what that number is? No, it could be 1. It could be 5. It's not numbered, so we don't know. But it's definitely not 0. All right. What about this one? Is this proportional?
Yay or nay?
Good. Good. Huh? You can say what? Good. Good. Good job. Yes. Good. Good. Everybody who has a board up is good now. All right. Faith. Why is that proportional?
Because it starts at 0.
And one more reason. Yusef? And it's a straight line, right? It has to start at 0, 0 and go at a steady rate, straight line. Good. Last one. That one, proportional. Yes, 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 yes. John McKenzie, you're right. Good, 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 good. All right, why is this one not? You're right. Is it straight? Yeah, straight. But why is it proportional though?
Does it start at 0?
Yeah, it's starting. This would actually, if you continue this, it's actually going to start in what we call negative. So that could be possibly -1 or it could be -5. It's not starting at 0, 0, the origin. All right, I'm going to give you some examples of maybe real life. And you tell me, are they proportional? The relationship between your age and your height. So, the age, think about it, the age and height, yes or no, is that proportional? As you get older, is that proportional?
No.
Shh, don't shout out answers. You're right. Good, 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 good. Good, 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 good. All right, now the fun part. Let's talk about, good Anna. Why wouldn't this one be proportional? Give me, Olivia, what do you think?
Because once you get past a certain age, you start shrinking.
So you're thinking about it. So if we have a graph,
Or you
when you're born, are you starting at 0, 0 in your height?
No, you're
No, you gotta start with some type. I think my daughter was 20 some inches. I don't know. And then you kind of grow really fast, and then you kind of start slowing down, and then you level out, and then old people shrink. They say.
Yeah.
Is that true, or is that just your body compressing?
Their bones
Their bones are breaking. I don't know if they're breaking.
I said merging.
All right, but literally, is it going at a constant rate? No. You know there are people that never stop growing. Have you ever heard about this?
No.
There was a guy when I was your age. His name was Andre the Giant. He was a pro wrestler, and it's actually it's almost a curse because our bodies are only supposed to support certain types of frames, and some people are born and they grow even into their 30s, 40s, 50s, and they never stop. And you get so big that your heart has trouble supporting that type of body, and that's why they don't live that long. He had a chance to change it, but he decided not to. All right, next one. What about the thickness of a book and how many pages are in a book? Is that proportional? Ooh. Don't say it out loud. Talk to me with your boards right now. Good. Good. I disagree. You might have a reason and it might be good. I'm just gonna say I disagree for right now. I'm gonna disagree with you guys. I say that's what I think too. I disagree with tomorrow. I think you're right, Cassidy. And then you two, I disagree. So this is literally 50-50. I disagree with you right now.
This is my reasoning.
Okay. Good. All right. Let's talk about it. The thickness of a book. Let me try to get a book so we can agree on it. All right. So let's say this is the book that we're talking about. Why I think this answer is. Will somebody give me your opinion? What do you think? All right, Haley.
I think it is proportional because if you can see the thickness has to be the same thickness as the binder.
Yeah. So if we think about it, I think let's just say this book has, let's just say 1,000 pages.
Well, thanks.
I'm so sorry.
Yeah.
Let's say it has 1,000 pages. If I cut it down to 500, would the thickness go down by half, pretty much?
Yes.
Yes. If it had no pages, would these covers touch each other and be 0?
No.
So if it had, yes, if it had no pages, these blue covers would be touching. It would be a 0 thickness. The more pages you get put into it, the thicker it's going to get. Each of these pages, well, it should be. Should each of these pages be the same thickness? So as it's going up at a constant rate. So yes, think about this graph. If it had no pages, it'd be right here, and it is going up very slightly, but it's going up constant. All right, what about this one? The relationship between the length of a square and the area. This is the last one. You're right, but you're guessing. You're right. Think. I disagree. I agree with this table, not chosen though. Good. No, and I disagree.
I have a good reason.
Good. No. Yes, I agree. Well, Haley already shared. Okay. What's your reasoning?
No.
Okay.
Because the area of a square is the length and the width,
Okay.
and you just want the length.
Huh?
You just want the length.
Well, if the length of a square, let's say, is 2, okay, the width would also be 2. I think that's kind of what they want to be given. What would the area of that be? So we have 4. Let's say we have another one. Give me another easy number to work with.
5.
5. So we have 5 and 5. What would the area of this one be?
20. 25. Oh. 5.
Area is length times width. It should be 25. I heard somebody say 3. What would that area be?
9.
9. Alright, so I'm going to use this thing called a graphing calculator to see what's happening here. What would it be if I had 1? 1 by 1, the area would be 1. I'm just going to order that. I'm going to put that as an order pair. I'm going to say this one is 2, 4. What would this order pair be? I'm going to say 5, 25. All right, let's put some of these into a graph. This is one of my favorite websites. It's called Desmos. Where's it at?
Have we used it?
Did the kids use it?
We have sometimes they have those interactive lessons we use.
Right.
I used it when I taught 8th grade more because it was graphing, but we haven't got to graphing yet, really. Can I show you this?
Sure.
After this.
I've been teaching at Normandy High School for the past 10 years, just taking some parental leave this year.
Yeah.
And I'm an intervention specialist, mostly in English, but I was in math, and they were just making Desmos a requirement for the air test.
Oh yeah, they're the one that does the calculator.
Yes. Is it it's kind of the same thing, right?
Mhm.
Do you guys don't use CPM math?
No.
Do you know what that is?
Yeah, college preparatory. Yeah, we do a California curriculum called Summit Platform.
Okay.
It's more for the other subjects that are they want them to do more project-based learning.
Okay.
So that's what that's for. All right. If I was to there's a way to draw this line. I'm not sure how to do it though. Do you know?
No.
Not right now. All right, here, look up here real quick. So I put all these points in.
I have 1, 1. This length times width is 1. The area is 1. 2 times 2 is 4. 3 times 3 is 9. We have 5 times 5 is 25. You can see 25 is off of it right now. If I zoomed out, you would see it.
Is this line proportional?
Yeah. Why? Yeah, it kind of looks like it. It definitely has some sort of relationship, but it's definitely not straight. I mean, if you think about it, if we were to make a straight line on these, it would kind of look like this, right? It would go up. It would go up like that. This type of line, so it's not straight, kind of hangs like a necklace. It's called a parabola. Parabola. Yeah. These sides are parabola. Yeah.
Believe it or not,
They use this shape for a lot of stuff. Those of you that play sports, anytime you punt a football or you kick a ball in the air or shoot a basketball, it travels in a parabola, a negative parabola. Here, watch. If I make it negative, it'll flip.
people that I was on the Browns field last weekend, and if you looked at
the football field, it was not flat. It's like this, very slightly, a negative parabola. Why do you think they do that? When the rain hits it, they want it to flow off the sides. When you drive on the freeway, they don't make the road flat. When you're driving on the freeway, it's like this, for the water to rush off. So you see this in everyday life. When they build stuff, they purposely make things with parabolas.
not everything is straight. Okay. I'm going to skip to notes, which is right here. We're going to use proportions
To do something that you already kind of know how to do, unit rate. So you don't need to write words. Pass them now. Hurry up.
Are we writing this down in our notebook?
Yes, and today is 11-6.
Mr. Garcia, do you want me to wait until they get back?
Yeah, I would preferably wait till we're done with notes. We got this, I think, 4 or 5 examples. But yeah. Yeah, you don't need it. Oh, yeah, later on. No, I'm recording it. I have to put it on my YouTube channel and they can watch it later. Okay, I'm gonna wait. We're gonna be spending a lot of time on proportions. You know what the graph looks like now. You know what the idea is. But now we're gonna actually use proportion, like a fraction equals a fraction. I'm gonna probably, I don't know, I'll probably do 4 or 5 lessons on it after this. Today I'm using it to do a unit rate. So this is actually like a 6th grade review lesson. But I sprinkled in some decimals and I sprinkled in 1 fraction. If you have a highlighter, I'm gonna say words over words a lot. That's like that's what I use to be consistent. I'll show you what it means in a second. It means when you're setting it up, whatever unit's on top, you want to make sure you use it for both numerators. Whatever word's on bottom, let's say dollars, you want to make sure you're doing dollars and dollars. As long as you're consistent, you will not mess this up. Like you could have 2 or 3 or 4 different ways of setting it up, and all of you will get the right answer as long as you're consistent. And that's why I say use words over words. At least use letters over letters if they're different. We good? All right, I'll wait. You want me to use this? You want me to put it away? You're full of water. Oh, it's not going to put it away. I just don't want to embarrass myself by dropping it on the floor. I hit you. Did it hurt? In your own words, what's unit rate mean? Anybody got an example again of a unit rate? I think I gave it to you before. Unit rate. An example, or what does it mean? Miles per 1 hour, right? Rate is how much for one. Gas is $2.55 per 1 gallon. It's always going to be 1. All right, I'm going to move. If gentlemen, are you drawing on my board in pencil? All right. Don't scratch it. No. Is it all messed up now? All right. A 4-pack of Frappuccinos costs $10.88. How much does each cost? Now, I know what you're thinking. I could just set this up and divide by 4. I want to practice proportional ways to use this. So I'm practicing a different way. Got me? We're going to use this way to solve other problems. So I'm going to set up words over words. Give me the 2 things that you think we should use. What are the 2 things we're comparing? Josie, give me one. Frappuccinos. What's the other thing that we're, Miranda? Dollars. And if you go to the last slide, it makes sense to always put money on top. So I'm going to say dollars over frap. Words over words. Okay, now I can plug in. What number do you think I'm going to put next to the dollars? Samara, what do you think?
10.88.
Yeah, so I'm going to have $10.88 over, okay? Yes, this is the most important part of the notes, is setting up these examples, because we're going to use these for a lot of different things. What number goes under next to Muhammad? 4. 4 of them cost $10. Maybe I should change colors so you can follow easier. Four of them cost $10.88. Now you have the equal side. You go on the other side. Now that I have that set up, you could use this to solve any problem. You could figure out how much 42 of them cost. You could figure out how much 782 of them cost. But we want to know how much does one of them cost. So do I want to put one on top or on bottom? Bottom. And then we don't know how much it costs, so I'm going to put X. All right. That's what I mean by words over words. Is that, does that make sense? Or?
It sort of makes sense.
It will make sense later. Okay. So now, when you're solving these, you're going to hear me say, multiply by what you know and divide by the outside. So when you're looking across, do you know both of these, or do you not know one of them? You don't know this one. Do you know both of these? Okay. Yes, you do. You see 1088 and 1. So I'm going to highlight this time. You highlight across the ones you know, and then you divide by the outside. What is 1088 times 1? 1088. And then you're going to have 1088 divided by 4. Four goes into 10 2 times, makes 8. Don't forget the decimal like I did. 4 goes into 28 7 times. And 4 goes into 8 2. I was recording it for you. Who dressed up today? Huh? So anyway, our answer should be, so you multiply, divide by 4, and you would get $2.72 per Frappuccino. Is it?
Yeah.
Well, that's the thing. At Starbucks, you don't want to buy them in a packs, right? Like Target, they have those 4-packs. That's what I was thinking one day. This one. If you ever see that slash, that means per. Or you can actually write the word per, P-E-R. It's $2.72 for 1 Frappuccino. The most important part of this lesson is practicing this thing right here. That. This is what I want to make sure that we can do. Questions? Yeah.
Are we about to do another segment?
Are you what?
Are we about to do another segment?
Oh, I have 3 more after this. You good? Yeah, question.
So, like, in the beginning of the you were explaining this, you said not to do just $10 and 88 cents divided by 4. But that's what we ended up doing.
That's what you end up doing. What I didn't want you to do is just have this in your notebook. I wanted you to have this. So I wanted to make sure that we're practicing this idea. Because we're going to use it for a lot of different types of stuff. I know this is an easy problem that you could just have done this, but I was trying to make sure that. You see why this became this though? Does that make sense? Alright. Let's try this one. Mr. Hicks drives 468 miles in 6 hours and 30 minutes. How fast is he driving? Give me words over words.
I have a question about the last one.
Yeah, last one.
What is a frappuccino?
Frappuccino is like a coffee that's cold, I think. They come in like
So basically, like ice coffee.
Don't drink it. It's too
It's
young.
not ice
I
coffee.
had a
That's
frappuccino and it has caffeine and stuff in it. And you say this is a coffee stunts your growth. I had a frappuccino once when I was 12. I stopped growing that day. That's why I'm so short.
No way.
I'm shorter than my dad and my brother.
Okay, so I drink Coke.
What?
I drink it.
Well, I already did the damage. I might as well.
I hate coffee.
Okay. Okay, write this down, and then we're gonna identify words over words. If you want to move ahead, actually, I'm gonna wait on that. We'll wait on that.
Band-Aid.
All right, you guys should probably have at least most of this done. It's not going anywhere. All right, somebody give me words over words. What do you think we want to do this? So forget about the numbers. The first word she said was, and the other word you said was miles and hours. So we're going to put miles over hours. Okay, now you're going to plug in what you know. Shawnee.
Does it matter if the mouse is on the bottom of the hours or on top? Does it matter?
No, but and I'll show you that in a second. I'll do it a second time here in a second. I'll upload it. All right, let's go back to this stuff. Haley,
What hours do we have to put 6 hours and 30 minutes?
we're gonna talk about that. How many miles do you think I'm gonna put here though? What am I?
468.
468. Now to the part that Haley's saying. Do we put 6 hours 30 minutes?
I don't know.
How many hours is 6 hours and 30 minutes?
How many hours?
Good. 6 and a half. Is it not a half hour, 30 minutes?
Yeah, I said middle.
It's in the middle. 30 minutes, a half hour. So I'm going to put 6.5.
Mr. Garcia,
Yeah.
can you add them all up to minutes?
If you changed it to miles per minute, then you'd have to convert that to minutes. But yeah, you could do that.
How is this going to help us find out fast he's driving?
Because when you think about unit rate, you want to go how fast he's going in 1 hour, right? So where am I going to put 1 at? On the top or bottom? 1 on bottom. Alright, what am I going to circle? What are the two numbers I know? Let's go with Tiffany. What are the two more? Yeah. What are the two numbers across from each other? What about yes or no? Do you know both of these? Which one don't you know? You don't know the X. Now let's look at this one. Do you know both of these? Okay, so I'm going to circle these two and multiply. Multiply by what you know. 468 times 1 is 468 divided by 6.5. Oh, this is uglier than I thought it was going to be. Alright. Let's move over 1. Move over 1. Does 65 go into 4? No. Does it go into 46? No. Alright, somebody give me a guess. How many times do you think it can go into 468? Haley?
Estimate, guess we're gonna go 8 times.
Too big.
7.
Let's see.
No, 6.
You want to try 6?
Too low.
So it's going to
7.
be 7? Is that the wind?
Yeah.
Yes.
It's screaming because it's too hot.
We could open the windows. This is too hot.
Yeah.
Alright,
I'll open them.
thanks. Alright, 7 plus 5 is 35. I was wearing this like really nice sweater. I was like, oh, my outfit's on point today. And I walked in, I'm like, I can't live like this. 42, is that going to be 45? Alright, so we got 455. Subtract. 65 goes to 130 twice, and it's done. It's done. 72. So that means Mr. Hicks is driving 72 miles per hour.
Especially if he was driving a
Probably.
Jeep, it would break down.
I bet you what?
If he was driving a Jeep, it would break down by now.
I drive a Jeep, it never broke down.
My stepdad drives a Jeep, he has problems with it.
What year is it?
It's a 2001.
So
That's way
it's 20 years old. What do you expect it to do?
It's still
Still,
running.
like there's Fords, there's much better cars. Honda's run
If you
forever.
drive anything that's 2001, it's gonna have trouble.
Not a Honda. Honda keeps going.
You'll find a way to win.
Alright, I think somebody had a good question. I forget who it was, but they go, hey, what if we flip these? So what if we said, what if we had hours over miles? Well, if you did it, would you get the same answer? Let's see. We would have hours would be 6 over 468, and then we want to find out how fast is he driving. Well, we want to know how fast he's going in 1 hour. So are we still multiplying 468 times 1 and then dividing by 6.5? So yes, it doesn't matter. But which one makes more sense? Miles per hour or yeah. So make sure you think about that too. That's why I told you to put dollars on top. How much for one of something? That makes more sense. Alright, a dozen eggs. Try this one on your own. Does everybody know how many a dozen is? 12.
How many tables is there for?
There's going to be 4 with a decimal, and then I'm going to throw 1 in with a fraction. We'll spend more time with fractions later, but technically the fraction one is your 7th grade standard.
Yes. This class goes and oh, it's 9:20. The clock's not working. I don't know. It was working yesterday. I don't know what happened to it.
Do we move it at all, or can we leave it?
You keep it there and you bring it up. It's a good question.
Got it. First, yeah, it would be money and then eggs.
Yeah, it's money. Money per one egg.
I can walk around and check. If you're having trouble, raise your hand and I'll help you.
Yeah.
Alright, set it up. We want dollars on top of it. Dollars. So you circle these. I want you to circle these. Type in 4, 1, 2, 5. Times 1 equals divided by no, that's right.
I don't know. How many times stuff sounds what?
That's what's, oh, divided by 12. Let me show you something. If you go up to it, 4 and 25, that's good, right? Divided by not 1, 12. So you can change it there. So how much money is going to cover up all those digits? How many digits? Yes, that's right.
Alright. This goes into that. So put a decimal right there behind the X. And then 4 is 42. 3 times 36. Alright, somebody want to come up and we set up the proportion. Just set up the words over words and then fill it in. Alright, Shawnee can try it.
Wait, should I talk it through or?
Do what you want to do.
Oh,
Talk it through. I like that better.
should I write the answer and stuff too?
Just set it up for now.
Okay. So, I'm sorry.
ring sounds like it's screaming.
Okay, what is happening? Take it. Oh,
I think your notebook's touching it. That's why.
no. Like that?
What do you guys think? Here, back away. Don't leave too much. You guys like what she has? I do. I think there's one little thing I would fix. Anybody have something that they had differently than what she has? Yeah. Okay. Instead of dozen, it might make sense for change that to eggs. So it's $4.25 for 12 eggs, and how much would it cost for one? And you would multiply by what you know, divide by the outside. So if you do this correctly, you end up with. Does anybody 35 cents per egg? Do we want to go through the division?
No.
Alright, well, we're gonna go through it because on some of the checkpoints where I had you guys divide, what's the time frame? Alright, 4.25 and dividing by 12. First question somebody came up and asked me, they go, do you have to move the decimal?
No.
No, because there's nothing to move out here, so you can just pop it right up there. Does 12 go to 4? No. Does it go to 42?
Yes.
3 times to make 36. You subtract that, you get 6, bring down a 5. This goes into that 5 times to make 60. You're left with 5. I go one more spot. Bring a 0, bring it down. That goes into that 4 times. So now I know I'm not rounding up to 36. I'm going to call it 35. Do I have to keep going? No, because we're rounding to the nearest cent, which is 35 cents. Has anybody got a Fitbit charger by chance?
I do, but I left it at my house today.
Alright, Carter runs 24.5 miles per week. How many miles does he run each day? Try this one on your own. Who does? Oh, can I use it?
Mr. Garcia, you have a YouTube video with the charger Carter getting yelled at.
I do. Are you sure it was him? Why? What?
Can you like this one too?
Oh, really? You know, some good ones are with me and Ben Van Shore. We got some good videos. Van Tracy coming in. Van Tracy.
We'll be right back.
Yeah, I'll help you in 1 second. I got it. You multiply this times this and then divide. You're gonna divide by 7. Alright. Divided by 7. Alright, Josie. You want to set it up? Or you want me to? Jaden. Pay attention, please. Yeah, put words over words so you're missing that part. Jaden, for a second time in 20 seconds. I'm talking. You're not being respectful. She got an answer? You didn't write it down. Did you? Miles and week. Alright, keep filling in and we'll come back to it. Yeah, that's right. That's what I messed up. Get that out of your ear. Your decibels and stuff. Why did you move it? You want to keep it there. There you go.
Should I keep going?
Stop there. Yeah. As long as I'm your teacher, you do. Because here's the thing, we're gonna get the further problems. Alright. Good job. The only thing, is there any critique that you would make? I love almost everything I see. Olivia, what do you think? Weeks to days, yeah. So it's a great idea, but we're gonna go days. We're gonna make it a little conversion. He runs 24.5 miles in 7 days. How much is he running each day if he runs the same amount? 24.5 times 1 is 24.5 divided by 7. Jaden? Good. So its answer we should have here is 3.5 miles per day. Alright. Let's go to the last one before I give you your homework. I just want you to set it up.
You're gonna do
Yeah, homework.
so do yours.
Elizabeth. Hilly. Yes, Johnny.
I have a question about the last one.
Yeah, last one.
Alright. So I know, like, let's say this problem like is on the test. Will we like get back points if we put week instead of day?
No. Because in my mind, I'm saying the person is thinking about distance over time. And if they set it up, the whole idea of this is to set it up correctly.
Okay.
Alright, Elizabeth runs 1/8 of a mile in 1/3 of a minute. This is a 7th grade standard. Fractions. Doing what we're doing, but doing them with fractions. This is also on the platform. So, I'm going to set this one up with you. So at least have it written down. Don't come up to me trying to say unit rate. I'm specifically going to look for this example if you come up. Oh, show me the unit rate examples with fractions. We're going to spend more time on examples like this, but I just wanted to show it to you. Alright. You guys still need time, right? Should I like get pictures of these kids running? Alright, you work on that, I'll work on cropping photos. Don't tell her though.
Where did my Elizabeth, I know where you can find some running. Are you okay?
Oh, I can't do it because I'm recording my lesson, so it's going to show me everything on my screen.
Okay.
No, we can't do that. I can't do that.
I know where you can find some pictures.
Cause, huh?
I know where you can find some.
I'll do it next time, and then if you guys remind me, I'll come back and show you. I can't do it when it's recording because if I go to our school, it's gonna show people's like private information. I can't put that on YouTube.
You can get into the boxers. Do you upload a video every week?
What?
Do you upload video every week?
Usually when I do notes. Alright, yes.
Alright. I have a question about staff.
Okay. How about this? Give me words over words. What did you do for that?
Smile over
Shh. Miles over minutes. Does that make sense? Yes. Okay. I'm gonna change color on this. Alright, miles is gonna be 1/8 over 1/3.
And then equals x over
Say it again.
x over.
How many miles is she going in 1 minute? Okay. Can you have this right here? Draw an arrow off to the side. This right here is called a complex fraction. You're allowed to have a fraction over a fraction. They call it complex, probably because it looks confusing. You still follow the same rules. What are the two numbers that you know or you're going to multiply? Somebody other than Shawnee. Say it. Yeah. 1/8 times 1. What is 1/8 times 1? Divide by the outside. What's the outside? So you have 1/8 divided by 1/3. Anybody remember the saying for this?
You can change it.
Test.
Cheated?
Cheated?
Ice cream.
Yeah.
I
Keep
didn't
it.
know.
Keep it. Change it. Flip it. So what is she running? She's running 3/8 miles per minute.
So fast.
I think that might be unrealistic. That would be yeah, that would be like world class speed. This is not realistic.
5 miles per hour.
Huh?
Well, the fastest person on earth was
But you know what? At least the math is good.
you change it to a decimal, wouldn't it be 1/66?
That would be 0.375 miles per minute.
Are you allowed to change it into a decimal?
Yes. I mean,
At the last one. Are we done with our notebooks? Can I pass them out?
Alright, we have 9 minutes. I say on here, I say show work, preferably on the back because it's blank. If you're a tiny writer, you can maybe fit it off to the side. Alright, you get the back. You can get the middle row.
Can I get front row?
You can get the front row. And who are we missing?
Sammy and Nora.
Is this a good time to go get my matchstick for you?
Yeah, you can get.
Sammy this morning. Shahab was with her and Sammy was crying. So I don't know if she went to this boy or something.
Okay.